In this topic, we are going to look at some examples on further probabilities. Here we have a bag containing 3 green, 5 red, and 2 orange balls. 2 balls are taken out at random with replacements. What this means is that after the first ball is taken out, it will be put back into the bag before the second ball is taken out. We are asked to find the probability that the first ball is red and the second ball is orange. The probability that the first ball is red and the second ball is orange can be written as probability red and orange because we are taking out 2 balls. Since these two are independent events, we can write it as probability that the first ball is red times the probability that the second ball is orange. We know that the probability that the first ball is red is equals to 5/10 because there are 5 red balls and there are 10 balls in total. The probability of getting an orange ball will be, 2/10, and we multiply these two numbers together to give us 1/10 after simplifying. Next, we are asked to find the probability that the first ball is red and the second ball is orange. However, this time round, there is no replacement. The probability that the first ball is red and the second ball is orange will be equals to probability that the first ball is red times the probability that the second ball is orange. Now, the probability that the first ball is red will still be 5/10. However, this time round, the ball will not be replaced, and hence we have 9 balls remaining after the first red ball is taken out. And the probability of getting an orange now will be 2/9. After multiplying these two numbers and simplifying, we will have 1/9. Here, 2 balls are taken out at random, and this time it is with replacement again. We are asked to find the probability that both balls are red. Therefore, the probability that both balls are red will be equals to probability that the first ball is red and the second ball is also red. And we can use probability that the first ball is red times the probability that the second ball is red, because these two events are independent events. The probability that the first ball is red will be 5/10. Since there's replacements, the probability that the second ball is red is still 5/10. Multiplying and simplifying will give us 1/4. Now here we have the same question but without replacement. We are asked to find the probability that both balls are red. So we will have probability that the first ball is red times the probability that the second ball is red. Now the probability that the first ball is red is 5/10. However, since there's no replacement, after taking out the first red ball, we are left with only 4 red balls and 9 balls in total. And therefore, the probability of getting the second red ball will be 4/9. After multiplying and simplifying, we will have 2/9. In this question, we are asked to find the probability of getting a red and orange ball. And these 2 balls are taken out at random with replacements. So the probability of getting a red and an orange ball is equal to the probability that the first ball is red and the second ball is orange. However, we also have the scenario whereby the probability that the first ball is orange and the second ball is red. So there are 2 cases here, and these 2 cases are mutually exclusive events. The probability of getting a red is 5/10. Since there's a replacement, the probability of getting an orange is 2/10. And we have learned that if these 2 events are independent events, we will multiply these 2 probability. Similar here, the probability of getting an orange is 2/10. The probability of getting a red after replacement is 5/10. Now, what do we do with these 2 cases here? Yes, we will add up the probability of these 2 mutually exclusive events to give us the probability of getting a red and orange equals to 1/5. What happens if there is no replacements? Probability of getting a red and orange is equals to probability that the first ball is red, second ball is orange, or the first ball is orange and the second ball is red. And therefore, we have 5 over 10, which is a probability that the first ball is red. However, after taking out the first red ball, we will have 2 orange balls out of 9 remaining balls. The probability that we'll be getting an orange will be 2 over 10. And after taking out 1 orange ball, we will have the probability of getting a red to be 5 over 9. Once again, we will add up the probability of these two mutually exclusive events to give us the probability of getting a red and orange, or the probability of getting an orange and red ball, which is equals to 2 over 9. Next, we ask to find the probability of getting two balls of the same color without replacement. Now, it can be green, green, red, red, or orange, orange. Now, there's a few cases here. We can use a tree diagram to help us to find the answer. Since we are getting two balls, so there are two stages. The first stage being the drawing of the first ball. Since there are three different colors, there are three different possible outcomes: getting a green, a red, or an orange. The second stage is getting the second ball. If the first ball is green, the second ball can be a green, red, or orange. If the first ball is red, the second ball can also be a red, green, and orange. And finally, if the first ball is orange, the second ball can still be a red, green, or orange. The final possible outcomes are green, 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 red, green, orange, and so on. Each of these outcomes are of the same color. Yes, we have green, green, red, red, or orange, orange. In this case, we cannot say that the probability of getting the same color is just 3 over 9 or 1 over 3, because here we have 3 greens, 5 reds, and 2 orange, instead of having just 1 green, 1 red, 1 orange. So how do we find the answer then? Now we need to write down the probability for each branch here. For instance, the probability of getting the first green will be 3 over 10. Now there is no replacement. Therefore, the probability of getting the second green will be 2 over 9. The probability of getting the second red will be 5 over 9. And the probability of getting the second orange will be 2 over 9. Now, if you notice that adding up all these three fractions here, we will get 1. Next, the probability of getting a red for the first ball will be 5 over 10. The probability of getting a green after the first ball is removed is 3 over 9. The probability of getting the second red will be now 4 over 9. And the probability of getting the second orange will be 2 over 9. Once again, the numbers add up to 1. Finally, the probability of getting an orange for the first ball is 2 over 10. After one of the orange ball is removed, the probability of getting the second ball to be green is 3 over 9. The probability of getting the second ball to be red is 5 over 9. And the probability of getting the second ball to be orange is 1 over 9. Again, all these numbers add up to 1. Similarly, for the first stage, all these numbers here also add up to 1. So the probability of getting two same colors will be equals to green, green, or red, red, or orange, orange. And for the probability of getting a green, green, we will have 3 over 10 times 2 over 9, because it is the probability of getting a green and a green. Likewise, for probability of getting a red and a red will be 5 over 10 times 4 over 9. The probability of getting an orange, orange will be 2 over 10 times 1 over 9. Since these are three different cases or three different mutually exclusive events, we will have to add up these three probabilities to give us 14 over 45, which is very different from 1 over 3 if there's only one green ball, one red ball, and one orange ball. Now, what is the probability of getting different colors? Now, it will be the rest of these cases here. However, there's too many numbers to multiply and add, but we know that. But we can use the probability of getting different colors is equals to 1 minus probability of getting same colors. Because if it's not of the same colors, then it must be different colors. And we have found previously that the probability of getting same colors is 14 over 45. And here we will have 1 minus 14 over 45 to give us 31 over 45 for the probability of getting different colors. Now what happens if the same question is now with replacements? The probability of getting a green, red, and orange will always be 3 over 10, 5 over 10, and 2 over 10. It will always be the same because the balls is always replaced after the first ball is taken out. And the probability of getting a green and orange will be is either green, orange, or orange, green. It will be 3 over 10 times 2 over 10 plus 2 over 10 times 3 over 10. Simplifying, we will have 3 over 25. In summary, if we are finding the answers along the branches, we will multiply. If we are asked to find the probability of getting a green and orange, without saying which one is the first or second, we will use the probability of getting a green and orange or probability of getting an orange and green. For n, we will use multiply, and for O, we will use plus. Now, if there are different scenarios leading to the outcome, we will need to add the probabilities for these different scenarios. And that's all for this topic.